Hi everybody, this is Mrs. Sykes and today we are talking about transpiration. And this is one of these topics where people get a bit stuck and a bit confused, when actually it's really quite straightforward. The kind of question that you get on the topic of transpiration is usually quite difficult to decipher, difficult to understand what it's asking you to do. So for example, describe the conditions that increase the rate of transpiration. Most of you won't know what that means in terms of exactly what the examiner wants you to write down, even if the question itself makes a lot of sense to you. But if I rephrase this all, it should be a lot clearer. What weather helps dry clothes on the washing line is a question that you can all answer. And it's exactly the same answer to this question as the one that we've looked at before. So, if you've got some washing drying on the line and you want it to dry as quickly as possible, then you want the weather to be hot, you want the weather to be dry, and you want it to be windy. And those three things will cause the water to leave your clothes as quickly as possible so that they dry. Transpiration is when plants dry out. So if we go back to where we were at the beginning, conditions, if we put a word in there and we write weather, so describe the weather conditions that increase the rate, so speed up. So describe the weather conditions that speed up transpiration, leaves drying out. Describe the weather conditions that speed up leaves drying out. That question is suddenly a lot easier to understand. So we're now looking for weather, so something that you would talk about in terms of wind, you might talk about temperature, you might talk about the amount of sunshine or the amount of cloud. What weather makes this leaf give off water by evaporation most quickly? That's what the question wants to know. And again, it's the same three things: windy, sunny, hot. What happens in transpiration? The water leaves by evaporation because the leaves are dried out by the heat of the sun and by the wind. And the water that leaves from the surface of this leaf is replaced by water in the stem. So water disappears here and then it's replaced, sucked up like a straw, back into the leaf to keep the leaf hydrated. Because this water has now left, it sucks up water up the stem, and that water itself comes up through the roots, and the roots obviously get that water from the soil. So transpiration is the loss of water from leaves caused by it being hot, dry and windy, and the water travelling through the plant to replace it. And that's what transpiration is. Water leaving the plant and being replaced by water from lower down the plant. And that's called transpiration. This continuous line of water replacing is called the transpiration stream, like a stream of water, which again makes sense. So the transpiration stream is the water going up the plant to replace everything that's been lost because of the evaporation that's taken place. Now you might come across this particular piece of equipment. It's called a potometer. And this is the most bog standard and most basic version of the diagram you've got. So you've got some kind of plant or other that's had its roots cut off. So here you have got an empty stem and it is attached to some kind of clear straw with a little air bubble in it. And as the water leaves by transpiration, as it will do, water from below replaces it, and that water is soaked up through this capillary tubing. So the air bubble moves that way. So you can measure the uptake of water, the transpiration, by measuring in centimetres or in millimetres how far that bubble has gone. So if it gets to here, you get your ruler out, you go, right, it has gone 4 centimetres in however long you gave it. And depending on how long you were given, let's say that it was 4 centimetres in 60 seconds, then you would say that it's 4 centimetres per minute is the rate of transpiration. Okay? There's one more thing that you need to bear in mind with transpiration. There are 2 processes going on. Transpiration is when we evaporate the water off the leaves, but leaves are also doing something else at the same time. They are also doing photosynthesis. And photosynthesis is using some of that water to be making glucose. So some of the water evaporates, fair enough. Some of the water is used for photosynthesis, fair enough. So this uptake measurement that you get is assuming that it's only this. It's assuming it's only transpiration, but unfortunately, it also includes photosynthesis. And conversely, you sometimes get experiments where they use this piece of equipment, this potometer, to measure the rate of photosynthesis. Because if it's using water for photosynthesis, this bubble will move. But don't forget, it also measures the amount of transpiration. So this movement of this bubble shows you 2 things. Transpiration plus photosynthesis. And as long as you remember that it's both processes, it's absolutely fine. So, going back to our original exam question, describe the conditions that increase the rate of transpiration. So we want it to be hot, we want it to be dry, and we want it to be windy. Those conditions increase the rate of water evaporating off the leaves, and then the water is replaced due to the transpiration stream. This can be measured by setting up a capillary tube, or the posh word is a potometer, and measuring how far an air bubble travels, giving you a rough idea of how much water has been lost. Okay. And that is transpiration in a nutshell.